Welcome to our video on the Cryo correlative hardware solution. This solution enables movement of a sample between the light microscope and the scanning electron microscope, or a FIB-SEM, under cryogenic conditions. Before we get to a full cryo demo, let's look at some of the features of this solution and how it works. So let's get into this. The key to this whole thing is the universal holder. Now the universal holder comes in a couple of different varieties. One can hold 2 TEM grids and one can hold 3mm planchettes. The holder has two small holes over on the left hand side, which you can squeeze together and basically grip them. And what this means is it allows easier handling as well as a mechanism to secure the holder into various different locations within the whole setup. And so as you see, you squeeze it together, slide it in, release by taking the tweezers out, and that basically makes the thing sort of expand slightly and secures it firmly in whichever location you've put it. So once the universal holder is loaded, we can load our TEM grids in from a grid box. Before we do that though, we need to lock the holder in the open position. What that does is it opens a set of jaws, because there's a pin that as you slide the mechanism over, there's a pin that comes up and just opens the jaws. So to do that we need a slightly more robust set of tweezers, because it can be quite stiff, particularly under cryo conditions. So once that's done, those jaws are open, we can then take the tweezers and move, using the pivot function, we can move the load station to a nearly 90-degree position. And what that means is that when we put our TEM grids in the right place and we let go, they will actually move down the sort of chutes into the universal holder. Obviously things can go wrong. Sometimes TEM grids get dropped, so if that obviously happens, that's unfortunate. But we can obviously load another. The point is we get at least one or maybe two grids in there. Once that's done, we can actually reverse that process and push the pin over to the closed position, and that will clamp the TEM grid securely. So with those TEM grids loaded into the universal holder, we are going to move the tilt table back to flat, and we're going to slide the pin across to the closed position, and what you can see is actually the jaws close. You should be able to see them on this video. Maybe you wouldn't see them under liquid nitrogen, which is why we've shown you that here dry, and so you've got good visibility. Next thing is to actually remove the universal holder from this loading station, and we're going to move it across to the LINCAM adapter. So we're going to put the tweezers in, we're going to squeeze to get the holder out, and then we're going to move that across to the adapter. Now the adapter is required because the LINCAM CMS 196 stage actually has little magnets on it, and the universal holder doesn't, because that ultimately will go into the electron microscope, and we don't want a system with magnets on there. So we have to go via the universal holder, and again the position that we move that to is over on the left hand side. We've got sort of a carrier. You can orient that however you want, depending on whether you're left or right handed, but basically we're gonna move that across, and we're going to squeeze, and we're going to slide that in. With the universal holder now secured in the adapter, it's time to move both of those things across to a box. Now the box is there because ultimately both the adapter and the universal stage are going to be moved out of this loading station across to the CMS 196, which equally would be waiting ready and cooled to accept the box. And so before we do that, we're able to add a lid, and again the lid is there, as is the box, to reduce contamination, because the box is going to be passed through air momentarily, and in that very short period of time it would definitely be possible to pick up moisture and contamination. The box itself is secured using a sliding mechanism. We slide left to lock it in place, and we slide it right to remove it. And so obviously if you're then doing that in the CMS 196, the mechanism's the same. When we bring it back, we do the reverse. We drop it down and then we slide it left to secure it, just so that the box itself is not moving away or taking the lid off and putting the lid on, and equally trying to take the adapter and the stage out. So now it's come time to actually move that box out across to the CMS 196. And again, this is being done at room temperature, but imagine this is full of liquid nitrogen. We've effectively got the CMS, which has an equivalent adapter. We've already discussed the adapter, so we basically grip the box and we swiftly relocate that over to the CMS 196, and we dock it in the exact same way. We would then remove the lid, again grip the universal holder, which would also pick up the adapter with it, and we transfer that over to the bridge of the CMS 196, flip back the cover, and at that point the TEM grids or the planchets are exposed, and we can do our light microscopy. Obviously we're then going to want to reverse that process, so close the cover, carefully move the adapter and the universal holder across, put them back in the box, put the lid back on, and then you're ready to transfer back to the cryocorrelative loading stage. Okay, we are back in the correlative cryo loading station. We're going to remove the lid from the box, put that back in its correct position, and now we need to transfer into the CEM stage. The stage is designed to accept the universal holder, but of course it must be removed from the link ham adapter. And so first thing we must do is to move the adapter holder over, and to do that we're going to grip the universal holder so that the whole thing comes together. And what's really good about this is that it has a magnetized bottom, so what it should do is it should self-seat over in the orientation we want it to. We grip, and then basically we're going to slide that over, and we're going to slide that into the cryo holder, which is the quorum cryo sledge that can go into the SEM. Now it's worth noting that the same shape design has been used for both parts that accept the universal holder, and that is basically we can always do this kind of squeeze and slide. There's a rim around the edge, and say if you look at them on the video you'll see they're basically pretty much identical. Obviously they serve slightly different purposes, and so we should have a very smooth transition. And again, you know, depending on whether you're left or right-handed, you might need to play with these positions, but effectively we can slide it very smoothly from one place to the next. And so now the cryo shuttle is, you'll see the cryo shuttle is there. That is held in a horizontal position, and this is absolutely critical when performing this step, because what we don't want is this, we don't want this sledge moving around. So the sledge or the shuttle, depending on which terminology you like to use, is held by a pivoting clip, and what that does is it basically stops the stage tipping forwards. We do want it to tip forwards, but only when we want it to tip forwards. And so when we are ready for that, we can swivel the clip, and then we can actually pivot the stage into a from a horizontal to a vertical position. With the Cryo shuttle now in the correct position, which is the vertical position, we're ready to engage the Cryo transfer arm. The shuttle can be moved into the prep stage of the CLEM, and the shuttle is basically kept under vacuum during that process, courtesy of a small vacuum pot that the shuttle is sort of pulled back into. In the event you're not ready to go to the CLEM, or at the end of a CLEM session, you might want to store the sample for further use. That is indeed possible. Rather than needing to transfer the sample back to a TEM box and risk losing the sample, dropping it, bending it, we actually have a storage box that comes with this system. And so we can actually store the whole universal stage, and then you could obviously transfer it back at a later date. So the storage box locks into position, and it actually has a magnetized lid that keeps it shut, again because we want to reduce contamination by frost. Alright, so we've seen this done warm and without nitrogen, so let's try to do it with the nitrogen. So we're going to start by adding nitrogen, and we're going to place the surround, or the top clear plastic part on, and then we're going to add some more nitrogen. And as you would have seen in Cryo SEM video earlier on, this can take a little while, so I'm going to be waiting before adding the lid, as we do get quite a lot of boil off, and yeah, basically the lid otherwise would just jump around. We get a lot of boiling as all of the room temperature surfaces cool down, so we need to top up the liquid nitrogen level, and in this system that's really important because we need to maintain the level above the level of the metal surfaces. As we can see, the boiling is going to start to slow down. We can basically slide the top over rather than place it down, and again that's another really important point, that we slide it across rather than just plonking it straight on top. This minimizes the amount of air that's actually forced into the chamber, because again, we're forcing air into the chamber. Cold, moist air could get in there and again lead to frost. So it's really important that we minimize frost as much as possible. So the next thing obviously is we're going to slush the nitrogen, which again means to put it under vacuum, and we're going to wait for that to freeze. Once it's frozen, we release the vacuum and we can start to load the sample. In this case, the sample we're going to be loading is going to be taken from a storage puck, which actually holds multiple TEM boxes for long-term storage. And obviously, you don't have to do this. It can just be a freshly frozen sample that's been frozen on a cryo plunge or on a high-pressure frozen planchette. We've obviously chosen to use a Cryo TEM box because we're demonstrating the TEM holder, universal holder. So once the box is loaded, the transfer tweezers are removed and the grid tweezers are pre-cooled. Pre-cooling is absolutely crucial, as we've mentioned earlier on this week. And again, we're going to pre-cool our screwdriver, and we would see a rapid bubble, which effectively means that all the tools are cooling down. there'll be a final hurrah as the bubbling just kind of goes a bit mental. And basically once that stops, it should be nice and still, and that means all of the tools are at liquid nitrogen temperature. So we can open the box with a screwdriver, and then we're going to cool a second pair of tweezers, and we're going to get the stage ready to load. The universal holder is already loaded and in the open position, I should just mention. Didn't think we needed to show you that again. You probably wouldn't have seen it anyway. And then we're going to take a grid from the TEM box and we're going to move that to the grid loader. And the grids should self-seat, and we should be able to just slide them down that little whatever you want to call it, slide maybe, chute perhaps. And what's going to happen then is we're going to, once the grid is in, or grids are in, we would lower and we would, so back to horizontal, and we would slide the pin across, which would close the jaws and secure the grids. And obviously that allows the universal holder to be removed. If that slider was still over, we couldn't actually remove it. So there's again two mechanisms for that. So this can now be moved to either location, either if we want to just do some SEM, or over to the LinCam adapter. So we're going to recool the screwdriver, and we're going to, at this point, we're going to tighten the box up just to make sure that the remaining grids are safe. We're going to grip and slide to remove, as you saw before, and we're going to release to secure, and slowly over the securing lever and tip the cryo shuttle to vertical. So we swing over the securing lever and we tip the cryo shuttle to vertical. Just a word on the transfer rod. The end of the rod has a dovetail bayonet fitting, meaning that it pushes and rotates through 90 degrees to engage or to disengage. And also there is a vacuum pot inside. This is the small silver inner chamber, and that has a door that closes and seals to protect the shuttle from air and moisture as we move it from the slushing pot, or the loading stage, whatever you want to call it, over to the prep stage. Before we do that, the rod must be cooled at the tip, because again we want a nice cold tip touching our nice cold sample rather than a room temperature tip. And that is then docked into the cryo shuttle. We then slide the remainder of the transfer hardware down the rod, so we sort of slide this white part down, and we're obviously looking to make a good seal with the opening. And once that's done, we place the system back under vacuum and we wait until it just goes to slushy state, and at that point we withdraw the rod up, brings a sample with it, and then we close the door, move the lever up, and then the sample is secured behind the door in the vacuum transfer pot, and it's ready to go over to the prep stage. Now the rod can be transferred to the prep stage and pumped. We wait, and when the correct vacuum is reached, we should see a green LED, meaning that we can drop the gate valve, open the vacuum pot and insert the rod into the prep chamber. There is a light to make it easier to see, so we can turn that on, and the sledge docks into the dovetail adapter, which is cooled. To open the covers over the TEM grids, we remove the shuttle and we rotate it, and then we tilt back and redock into the dovetail. This is now maintained at the set temperature of the prep stage, and we can coat if necessary. Once imaging is complete, the sample can be removed from the prep stage by withdrawing the sledge back into the small vacuum pot and closing the door. Vent and transfer back to the slushing pot. Place the transfer rod under vacuum and after 30 seconds open the vacuum pot. The sledge can then be reinserted into the slusher. The grid can be transferred to be stored in the universal holder, as we previously demonstrated, in the gold box with the magnetic lid, or transferred to a TEM storage box for further storage. To do this, we cool a pair of tweezers and we tilt the sledge to horizontal and secure with a pivoting clamp. Next, using finer tweezers, we grip and slide the universal holder out of the Cryo sledge and return it to the loading station. Again, using robust tweezers, we put the slider into the open position. We then need to cool a screwdriver and open the box. Now tilt the loading stage, retrieve the grid and transfer to the box. Then cool the screwdriver again if it's been removed already and secure the box lid. Now cool the box tweezers and transfer the box out to storage. While we observe these final steps being completed, it's worth mentioning that the system also comes with two other universal holders, one to accommodate high pressure frozen planchettes of the 3mm size, and another to accommodate the FEI or Thermofish or auto grids that hold TEM grids for those auto loading systems. In either case, we can see that this correlative cryo hardware should serve as a very robust way of moving between the different platforms and protecting the sample from frost and also damage.